Assalamu alaikum dear students. In previous video lecture we started solving exercise 10.1 and today I will show you few more problems of this very exercise. The first problem is find the slope of the line passing through the origin and the midpoint of the line P of 0 -4 and Q of 8 0. Now firstly we will find the midpoint of this line P and Q. We know that the midpoint of line P of x1 y1 and Q of x2 y2 is given by R of x1 xy, means midpoint of this P and Q is R whose coordinates are x and y, and these x and y's are given by R equals to R of x plus x1 plus x2 upon 2 and y1 plus y2 upon 2 by section formula. Here given point P of 0 -4 and Q of 8 0 are the points, which implies that x1 is 0, y1 is -4, x2 is 8, y2 is 0, and let R of xy, means R is the midpoint of PQ whose coordinates are x and y, be the midpoint of this PQ, which implies by section formula or by above expression R of xy equals to R of 0 plus 8 upon 2 minus 4 plus 0 upon 2, which implies after solving R equals to R of xy equals to R of 4 comma minus 2, which implies that midpoint of PQ is R whose coordinates are 4 and minus 2. So we have to find the slope of line which passes through this point R and origin. Origin means point 0 0 where x and y axis intersects. So you know that the slope of line passing through 2 points A of x1 y1 and B of x2 y2 is given by m, which is y2 minus y1 upon x2 minus x1. Here this line passes through this R of 4 and minus 2, R of 4 minus 2 and origin of 0 0, which implies that here this A of x1 y1 is R of 4 minus 2 and B of x2 y2 is of 0 0. Hence its slope is m, which is given by difference of y coordinates, that is -2 minus 0, upon difference of x coordinates, that is 4 minus 0, which is simply -2 upon 4, that is -1 by 2. Hence the slope of the line which passes through the origin and the midpoint of P04 Q80 is -1 upon 2. Second problem, without using the Pythagoras theorem, prove that A of 4 4, B of 3 5, C of -1 -1 are the vertices of right angled triangle ABC. You know that in Pythagoras theorem we use the distance concept. That is, if ABC is right angled triangle, which implies that hypotenuse square equals to base square plus perpendicular square, or if length square of one side equals to sum of length squares of other two sides, then given triangle is right angled triangle. But here we haven't to use this. Here we cannot use the Pythagoras theorem because it is given that we have to prove that A, B and C are the vertices of triangle without using this theorem. So this means that we will use the slope concept and we will show that the angle between any two lines, that is sides, in this triangle is 90, hence the given triangle is right angled triangle. Now if we have three vertices A, B and C, which implies that we have three sides. So slope of one side, that is AB, whose vertices are, whose endpoints are A of 4 4, B of 3 5 is m1, which is given by difference of y coordinates upon difference of x coordinates, which is simply -1. Similarly, slope of BC, side BC with vertices B of 3 5, C of -1 1 is given by m2, which is given by -1 -5 upon -1 -3, which is simply 3 by 2. And slope of CA, side CA with vertices C of -1 -1, A of 4 4 is given by -1. So for three sides we have three slopes, -1, 3/2 and 1, which implies that slope of AB into slope of CA equals to m1 into m3 is -1, which implies that m1 into m3 is -1. So this means that here we have two lines such that the product of their slopes is -1. Also, you know that the necessary and sufficient condition for two lines to be perpendicular is that the product of their slopes is -1. Here product of the slopes of sides AB and CA is -1, which implies that AB is perpendicular to CA. When AB is perpendicular to CA means the angle A here is 90. When angle A is 90 implies that the given triangle is a right angled triangle. Hence in this way we proved that this triangle is a right angled triangle without using the Pythagoras theorem. We have to find the slope of the line which makes an angle 30 degree with the positive direction of x-axis measured in anti-clockwise direction. So we have to find its slope. Firstly, we will find its angle of inclination. That is, angle of inclination is that angle which this line makes with the positive direction of x-axis. But here the given angle which it makes with the positive direction of y-axis. So this means that here it is positive direction of y, 0y is the positive direction, which implies that this is the angle, that is angle A is 30 degree, because this angle is 30 degree and we measure it with the positive direction of x-axis in anti-clockwise direction, means in positive direction. So this means this is the line AB such that it intersects the x-axis at B and y-axis at point A. So in this triangle A of B, angle A plus angle O plus angle B is 180, because sum of angles of triangle is 180. So substituting the values, here this angle O is 90 because x and y axes intersect at 90, which implies that angle B is 60 degree. Hence this angle B within this triangle is 60 degree. Let theta be the angle of inclination, which implies that this angle XBA plus angle B, means this 60 is 180 degree, because it is a linear pair of angles. Hence in this way angle XBA is 180 minus 60, that is 120 degree. Hence this angle theta, which is 120 degree, equals to XBA angle, is the angle of inclination which it makes with the positive direction of x-axis. So by definition of slope of this line is m of equals to tan theta, which is tan of 120. Tan of 120 is simply minus root 3, because tan 120 can be written as 190 plus 30, which is minus cot 30. Hence minus cot 30 is minus root 3, which implies that slope of this line is minus root 3. Find the value of x such that these 3 points x -1, 2, 1 and 4, 5 are collinear. We know that the 3 points A of x1, y1, B of x2, y2, C of x3, y3 are collinear if slope of AB equals to slope of BC, because these 3 points lies on the same line, which implies that slope of AB equals to slope of BC, which implies that y2 minus y1 upon x2 minus x1 is y3 minus y2 upon x3 minus x2. Here the given points are A of x1, y1 is x minus 1, B of x2, y2 is 2, 1, C of x3, y3 is 4, 5. So substituting in first, we simply get x equals to 1. So this means that the x is 1 implies, this implies that these 3 points x minus 1, 2, 5, 4 are collinear if x equals to 1. Find the angle between the line joining 3 minus 1 and 4 minus 2 and the x-axis. Here we will use the slope concept. Now here the slope of the line which is formed by joining 3 minus 1 and 4 minus 2 is given by this y2 minus y1 upon x2 minus x1, that is simply minus 1. Also the slope of x-axis is 0, that is mx slope of x-axis. Here m is the slope of the given line. We know that the acute angle between the two lines with slopes m1 and m2 is given by tan of theta equals to modulus of m2 minus m1 upon 1 plus m1 m2. Hence substituting the value of m2 equals to m equals to minus 1 and m1 equals to m of x equals to 0. So we simply get tan of theta equals to 1, which implies that theta equals to pi by 4 because tan of pi by 4 is 1, which implies that the angle which this line 3 minus 1 and 4 minus 2 makes with the x-axis is theta equals to pi by 4. Show that another problem. Show that a of minus 2 minus 1, b of 4 0, c of 3 3 and d of minus 3 2 are the vertices of parallelogram. You know that in parallelogram is that quadrilateral whose opposite sides are parallel. When opposite sides are parallel implies that the slopes of the opposite sides are equal. So when we have a quadrilateral with vertices a, b, c, d, which implies that we will firstly find the slope of line AB, BC, CD and DA. Now if the slope of AB equals to slope of CD and slope of BC equals to slope of DA, which implies that these two sides, these pair of opposite sides are parallel. Hence, if they are parallel implies that ABCD is parallelogram. So simply you have to find the slopes of AB, BC, CD and DA. So that is a required way to show that these four vertices are the vertices of parallelogram. Now if h of 0, a, b and 0k lies on line, show that a by h, b by k plus b by k is 1. Now these 3 points h0, ab and 0k lies on line implies that they are collinear. So using the condition of collinearity, you will prove that a by h plus b by k is 1. Now here we have a graph. X-axis in this graph, x-axis, this y-axis represents the population of the particular community or particular area in crores, while as y-x-axis represents the year. Here point A, we have a population graph. Here this point A on this graph means that in 1985, in year 1985, the population of this population is 92 crores, while as B represents the point. This means that population in 1995 is 97 crores. We have to find the slope of this line AB. So slope of this line is difference of this y coordinates upon difference of x coordinates. Here y coordinates represents the population in crores. So this means that it is 97 minus 92 upon 1995 minus 1985, that simply equals to 1 by 2. Hence this slope is 1 upon 2. Now we have to we have to use this very slope to find the population in year 2010. Let x be the population in 2010 in crores. So according to given graph, this line AB must pass to the point C of 2010 of x, which implies that they are collinear. These 3 points, that is point A, B and this given point C of 2010 x is collinear, which implies that slope of AB equals to slope of BC. Here slope of AB is 1 by 2 because we have to use this very concept. Now slope of BC equals to difference of y coordinates, that is x minus 97 upon 2010 minus 1995, which is simply x minus 97 upon 50. By cross multiplication you get x equals to 209 upon 2. Hence by division it is population in 104.5 crores. Here x is in crores, that is why we get here this fractional number. So this means that the population in 2010 is 104.5 crores. So inshallah tomorrow we will discuss the new topic of this chapter, that is different forms of straight line. So thank you.